Okay, so we're going to continue even more of 7-2. And this part is rationalizing radical expression denominators. And so our objective really is pretty much just that. We're going to rationalize denominators containing radical expressions. It's a little bit of a continuation of the previous lesson. The one big thing is that for a lot of these you can't even divide first. Some of them you can, some of them you can't. Just kind of depends. So let's go ahead and take a peek at this. This is all on page 372. And so the directions are just going to be to simplify, okay? And you need to rationalize any denominators. So we're going to simplify the expression. So I have my first one. I have 4 over the cube root of 3x squared y. Okay, so nothing that I can reduce because 4 is not in a root. And so remember, this is a cube root. So that means I'm going to have it 3 times. Okay, so I'm going to have to put 3x squared y in for each of them. 3x squared y and 3x squared y. So now I'm going to have my numerator. I'm just going to multiply straight across. The 4 doesn't combine with anything because it's not in a root. And then I'm going to have the cube root, and 3 times 3 is 9. X squared times x squared, 2 plus 2 is 4. And then y times y, 1 plus 1 is 2. And then my denominator is just going to be 3x squared y. Because again, I had a cube root and I had it 3 times. Therefore, because I multiplied it 3 times, it's going to be whatever's inside. Now at this point, I need to simplify as much as I can regarding this root. So the cube root of 9, now I know that what made up 9 was the 3 and the 3. So I could do this, but I know I'm not going to get a group of 3. So the 9's going to stay in. Now that x to the 4th, I'm going to have 4 divided by 3 because 3 is my root. 3 goes into 4 once with a remainder of 1. So that means I'm going to have x cube root of x. And then the 2, I know if I do 2 divided by 3, I get 0 with the remainder of 2. So what's going to happen in my numerator, I'm going to have 4x. And then I'm going to have the cube root of 9x, because of this down here, 9x and then y squared, all over the 3x squared y. Okay? And then I'm going to look outside here, outside of that cube root, and I'm going to see if I can reduce. And I can notice with the x's, I can reduce. So then, because x squared is bigger than x to the 1st, my x will be in the denominator. And then 2 minus 1 is 1, so I'm just going to write the 3x, x to the 1st, or just x. And then in my numerator, I'm just left with 4 cube root of 9xy squared. So that gives me my final answer, because the x in the numerator is now, it was joined with the denominator. So that is fully simplified. So it's very similar to one that you saw yesterday. There really isn't too much of a difference with it. Then let's look at number 2 that I have here. I have 4 minus the square root of 2 all over the square root of 2. Please, please, please resist the urge to say, oh, we're done. That's just 4. Because we're not. This is a binomial. It's not broken up. Okay, it's together. So what I'm going to have to do is I'm going to have to rationalize. Now because it's a square root, we only have to have it one more time to have my 2 here at the bottom. So it's going to be square root of 2 over square root of 2. I need to now distribute that square root of 2 to the numerators. the both parts of the numerator, I should say. So 4 times square root of 2 is going to be 4 square root of 2, minus square root of 2 times square root of 2 is going to be the square root of 4, which is 2. All over square root of 2 times square root of 2 is 2. We know that. And then I look at these three here, and I ask myself, do they all have something in common that I can reduce by? And they all have a 2 in common. So we can actually divide each of these by 2. So 4 divided by 2 is 2, so 2 square root of 2, minus 2 divided by 2 is 1. I have to write the 1 there. I can't just like make it disappear. All over 2 divided by 2 is 1. Now, because I have a 1 in the denominator, I actually don't even need that. So my final answer can be 2 square root of 2 minus 1. Again, please resist the urge to just say, oh, we're done there. No. It happens every year. I make a big deal about it, and I always have kids who do it. So please don't be part of that statistic. Don't be one of those kids that I'm talking about next year. Okay? Let's look at number 3. It's very similar to number 2. I have 6 minus the square root of 8 all over the square root of 8. Resist that urge to cross that out. You cannot do that. Please don't do that, okay? I will talk about you next year. I won't remember who does it, but you will be mentioned as a group because it happened last year and the year before that, okay? So you don't want to be part of that statistic. So I need to rationalize, so I'm going to multiply by the square root of 8 over the square root of 8. I'm going to distribute the square root of 8 to both parts of my numerator. So I'm going to have 6 square root of 8 minus 8, because square root of 8 times square root of 8 is just 8, all over square root of 8 times square root of 8 is 8. Okay? And actually, before I look at my 3 terms here, before I even do that, I need to actually simplify that square root of 8. Okay? So square root of 8, I can break that up into 4 and 2, and then 2